Okay, so this is kind of a bonus problem. It's the same problem that we had in the last video, but I wanted to show you how to use the quadratic formula with it, because you might be thinking, why didn't you just use the quadratic formula? You know, that would have solved the equation, and it would have. So I wanted to show that. We have another example of using the quadratic formula in another problem in the next video, so if you want to skip over this one, you could, but it doesn't hurt to see it twice. Sometimes the quadratic formula can be a little tricky. But we're setting the function equal to 0 to find the x-intercepts. So this is a quadratic equation, and we can use the quadratic formula, which, remember, if you have ax squared plus bx plus c equaling 0, then x equals plus, nope, not that. Been a while since I used the quadratic formula, I guess. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You've probably seen it somewhere in your past. To use the quadratic formula in this case, I'll show you a little trick. I would not just start plugging stuff in. Notice that all these coefficients are divisible by 2. So I would divide both sides by 2. Or multiply by 1/2 if you want to think of it that way. Makes my numbers smaller, and I haven't changed the equation, so it's just fine to do that. This will not factor, so there goes that idea. And now my a is 1, my b is 2, my c is the opposite of 2, or negative 2. Okay, so we're going to go over here and use the quadratic formula. Actually, that's the formula I'm going to use, but I'm going to write it over here on the left. So the opposite of b plus or minus the square root of b squared minus, you could put that in parentheses, minus 4 times a times c all over 2 times a. Now, you have to be really careful with your signs because it does make a difference. So, just make sure you're careful on that. We should come up with the same answer that we had on the previous screen because it's the same problem. So, the opposite of 2, negative 2, plus or minus, I'm going to have 4 plus 8 all over 2. That's going to give me negative 2 plus or minus the square root of 12 over 2. Now, you might say, oh, that doesn't look like what we had for the answer on the last one. And you're right. So we need to use our principles of simplifying a radical. So remember, 12 is 4 times 3, and you can take the square root of 4. So we're going to do that. So we'll have the negative 2 plus or minus 2 square root of 3 all over 1/2. By the way, these are real numbers, negative 2 plus 2 square root 3 over 2, and negative 2 minus 2 square root 3 over 2. Those are real numbers. There's no I in there, so they're not imaginary numbers. Okay. One way to do this from here is to factor out a 2 in the numerator. And then you can cancel those 2's. And now the answer should look similar to what we had before. We just need to write them as ordered pairs. Remember, you're solving for x, so we're saying x equals that. And we're going to write them as the x-intercepts, ordered pairs, negative 1 minus the square root of 3, comma 0, and negative 1 plus the square root of 3, comma 0. Those then are the x-intercepts, just like we had on the last one. Okay, so if you were thinking, hey, on the last problem, I wanted to use a quadratic formula, you certainly could have. Which way is easier? I don't know.